So we are done with the introduction to the ARM assembly. We did a few videos on the basics of the coding. We went over the code sections, allocating space, and then we did a little bit of the alignment, and we did the macros. Now we're going to move on and talk a little bit about the ARM architecture itself. We'll have some basics, nothing too deep, so that we know what's going on when we dive into the load and store instructions and how the data is moving from memory to registers and whatnot. So we'll also take a look at the registers, the generic or the general registers, and we will talk a little bit about the special registers. Then we'll talk about immediate values and addressing modes. As you have seen in the previous example, we were doing the recursive functions, and you see that we have registers here on the right hand side, and you see that they are filled up with certain values. So like, how big are these registers? How do they communicate with main memory? We also did a little bit of memory content in earlier videos. You can check those if you like. But we're going to talk a little bit more about the actual hardware before we continue with our ARM instructions. So first, let's take a look at the registers. You have been familiar with the original 16 registers that we worked with. Those are the common or system or general purpose registers. They are R0 all the way up to R15. You have seen these before when we did a few programs. They usually are located in the register tab. Each of these registers is a 32-bit register. They can hold up to 32-bit value. And some of them have special values, or they represent special, or they're used for certain things. For example, for example, a register R0 to R12 are your common registers. And then R13 is basically the stack pointer. R14 is used as the link register. Then R15 is the program counter. And then you have the CPSR, the current program status register, which is a special register. And after that, looking at those other abbreviations, you'll see that you have FIQ, supervisor, abort, IRQ, and undefined. Simply put, these are when you code in the future, if you code interrupts, so a fast interrupt, which is FIQ, or if you code for interrupts, IRQ, and so on, you get extra set of registers. These are called banked registers or whatnot. So you get an R8 register that will become available only if the program is executing an FIQ. You will get an extra, for example, R14 or a link register. So this will be the R14 specific to the FIQ and not R14 that was used in the user program. This is a little bit out of scope, so I'm not going to spend too much time here. Just know your registers actually are more than 16 registers. You have way more. It depends on the type of program, or it depends on whether or not you're doing an interrupt, or it depends on the mode that the program is executing in. Here is a little bit more about the architecture. I specifically wanted to go over some of the buses here that you have. So the architecture, the ARM architecture is simply like, this is a CPU core. This could be your Cortex CPU, and it communicates with peripherals over buses. And I would like to just mention, for example, that the bus wide width is 32 bits. So you are moving data back and forth in 32-bit values. So keep that in mind. So we've learned so far that the registers are 32 bits and the buses are 32 bits. In the ARM 7 TDM, this means that this core supports thumb instructions. So that's what the T4 is for. And then D for debugging, M for enhanced multiplication, and the I for embedded microcell. and it has a fast multiplier and so on. If we open up this ARM7 TDM, what do we have? You'll see here that you have your register bank, which is the registers that we just went over, 31 registers, including those special registers that are available in different modes and so forth. And you have a multiplier, a 32 by 8 multiplier, a variable shifter, you have a 32-bit ALU, and you have, again, you have your buses, you have your data bus, and you have some address bus, 32-bit address bus, which actually you can see also here. Slide. Address bus right here. So 32-bit address bus from 0 to 31, and so on. So why did I want to mention this? Because later when we deal with load store instructions or other types of instructions, multiply and whatnot, it's helpful to understand that this architecture that we're dealing with is a 32-bit architecture, and everything here for the most part is 32 bits. Again, the registers, the buses, the ALU, and so on. Here is a better view actually of that diagram. In case you missed it, that's the address I was referring to. The 32 address was hidden. Okay, the last two things we will talk about in ARM architecture is immediate values and addressing modes. I believe we can save them for another video. The immediate values, like how to generate and do immediate values in instructions, and then the ARM addressing mode will be probably its own video. So stay tuned, and I'll see you in the next video.